Hold your hands in front of your face right now. Spread them apart about 6 inches. Look at the gap between them. What do you see? Nothing. Empty air, vacant space, an absence of things. Your eyes confirm it. Your intuition agrees. There's nothing there. I used to believe that too. Then I learned what's actually happening in that gap, and I haven't looked at empty space the same way since. That 6 inches between your hands contains more activity than every stock exchange on earth combined, more violence than every war in human history, more energy than you can possibly imagine. Right now, in that empty gap, particles are being born and dying billions of times per second. Matter and antimatter are flashing into existence, colliding, annihilating, and vanishing before anything can detect them. The space between your hands is not empty, it's a war zone. And here's the part that should disturb you. This isn't metaphor, this isn't poetry, this is measured, confirmed, experimentally verified physics. We've built machines that detect the pressure of nothingness. We've measured the weight of empty space. We've calculated the energy contained in a vacuum, and the number is so absurd that physicists still argue about whether our equations are broken. You've been lied to your entire life. Every time someone pointed at empty space and called it nothing, they were wrong, not a little wrong. Completely, fundamentally, impossibly wrong. Let me show you what's actually there. First, forget everything you think you know about emptiness. When you look at a room and see empty space, your brain is doing something lazy. It's looking for objects, tables, chairs, people. When it doesn't find any, it labels that region as empty. But that's like looking at the ocean and calling it empty because you don't see any whales. The ocean isn't empty just because you can't see what's in it. Neither is space. What fills the vacuum isn't matter in the usual sense. It's something stranger. It's potential. It's probability. It's the ghostly presence of every particle that could exist but doesn't quite. In quantum mechanics, we learned something deeply unsettling about reality. Nature doesn't allow perfect stillness. It doesn't allow absolute zero. It doesn't allow true nothingness. Whenever you try to create a perfect vacuum, whenever you try to remove everything from a region of space, the universe pushes back. It fills the emptiness with fluctuations. This is called the Heisenberg uncertainty principle, and most people misunderstand it completely. They think it's about measurement. They think it means we can't know where a particle is because our instruments disturb it. Wrong. The uncertainty isn't in our knowledge. It's in reality itself. The universe genuinely doesn't decide certain things until it has to. A particle doesn't have a precise position and momentum at the same time, not because we can't measure them, because they don't exist simultaneously. Reality is fundamentally fuzzy at small scales. And here's where empty space stops being empty. If you take a region of space and remove all the matter and all the radiation, you're left with what physicists call the quantum vacuum. In classical physics, this vacuum would be perfect nothingness, zero energy, zero activity, pure emptiness. But quantum mechanics doesn't allow that. The uncertainty principle says you can't have a field with exactly zero energy, just like a particle can't have an exact position and exact momentum. A field can't have exactly zero fluctuation. There must be some minimum jitter, some baseline vibration, some irreducible trembling in the fabric of reality. This minimum energy is called zero-point energy, and it exists everywhere, in every cubic centimeter of space, including the gap between your hands. Think of it like this. Imagine a perfectly calm ocean. No waves, no ripples, complete stillness. That's what we imagine when we think of empty space. But quantum mechanics says perfect calm is impossible. Even if you could somehow remove every disturbance, the ocean would still have tiny random waves appearing and disappearing. Waves that pop up from nowhere, exist for a fraction of a second, and vanish before they can travel anywhere. That's what's happening in empty space. Except instead of water waves, it's particles, virtual particles, electron-positron pairs that flash into existence, borrow energy from nowhere, exist for an impossibly brief moment, and then annihilate each other before the universe notices they broke the rules. This sounds like science fiction, I know. The first time I heard it, I thought someone was making things up, but we've measured it. In 1948, a Dutch physicist named Hendrik Casimir made a prediction. He said that if you take two metal plates and put them very close together in a vacuum, something strange should happen. The plates should be pushed toward each other by nothing, not by air pressure, there's no air, not by gravity, the effect is too strong, not by any force anyone had ever measured before. The plates should be pushed together by the emptiness between them. Here's why. Virtual particles are constantly popping into existence everywhere, but between the plates there's only room for certain wavelengths, only certain types of fluctuations can fit. Outside the plates, all wavelengths are possible, so there's more vacuum energy outside than inside. That imbalance creates pressure from nothing, pushing the plates together. Casimir calculated the exact force. It depends on the distance between the plates. Move them closer, the force gets stronger. Move them apart, it gets weaker. He gave precise numbers. Decades later, in 1997, Steve Lamoureux measured it, and the measurements matched Casimir's predictions perfectly. We measured the pressure of emptiness. We weighed nothing, and nothing was heavy. This is when I stopped trusting my eyes, because every time I look at empty space now, I know I'm looking at a lie. The emptiness is a mask. Behind it, reality is churning. Particles are being born and dying. Energy is fluctuating. The vacuum is alive, and we're swimming in it every second of every day. The space inside your atoms is doing this. The space between you and the screen you're watching. The space between galaxies. All of it. Seething with virtual particles that refuse to let nothingness be nothing. Let me take you deeper, because the Casimir effect is just the beginning. It's the trailer before the movie, the appetizer before the feast. Once you understand what's really filling empty space, the Casimir effect will seem almost ordinary. Here's what I need you to understand about the universe. There is no such thing as empty space anywhere, ever. Space isn't a stage where physics happens. Space is physics. Every point in the universe, every location you can name, is filled with something called quantum fields, not particles, fields. Think of a field like an invisible ocean that fills all of reality, not just some regions, all of it. The entire universe is soaked in these fields. There's an electron field, a photon field, a quark field, a Higgs field, dozens of fields, all overlapping, all occupying the same space simultaneously. When we see a particle, we're not seeing a thing, we're seeing a ripple in a field. An electron isn't a tiny ball sitting in space. An electron is a vibration in the electron field. A photon isn't a bullet of light. A photon is a disturbance traveling through the electromagnetic field. This changes everything about how you should think about reality. In the old picture, you have empty space, and then you put particles in it, like marbles in an empty bowl. The space exists first. The particles come second. In the new picture, the fields exist everywhere, always. They are the foundation. When a field is calm, we call it vacuum. When a field vibrates, we call that vibration a particle. But the field is always there, waiting, ready to vibrate. So when you look at empty space, you're not looking at nothing. You're looking at calm fields, fields that aren't currently vibrating. But calm doesn't mean dead. Calm doesn't mean zero energy, because quantum mechanics doesn't allow zero. This is where virtual particles come from. The fields are always jittering, always fluctuating. Even in their lowest energy state, they can't sit perfectly still. And those fluctuations sometimes concentrate enough to look like particles. For an instant, a fraction of a second, an electron and a positron appear. They exist. They're real in that moment, but they don't have enough energy to stay real. So they find each other, collide, and annihilate. They borrow time from the universe and pay it back immediately. This is happening everywhere, right now, in the space between atoms, in the space between galaxies, in the space inside your body. Trillions of virtual particles being born and dying every second in every cubic centimeter of existence. I want to tell you about Willis Lamb. In 1947, Lamb was measuring the energy levels of hydrogen. Very precise measurements, tedious work. And he found something that shouldn't exist. A tiny difference between two energy states that classical physics said should be identical. The difference was small, incredibly small, about 1 part in a million, but it was there, persistent, real. The only way to explain it was virtual particles. The electron in hydrogen isn't just orbiting the proton, it's also interacting with the vacuum. Virtual photons are constantly appearing around it. Virtual electron-positron pairs are flickering in and out of existence nearby. All these ghosts affect the electron's energy. They shift it slightly, push it away from where classical physics predicted. This is called the Lamb shift. And when physicists calculated the effect of virtual particles, the prediction matched Lamb's measurement perfectly, to more than 6 decimal places. Let me say that again. We predicted the behavior of atoms by including the effects of particles that don't really exist. Ghost particles, temporary particles, particles that violate energy conservation and vanish before they can be caught. And it worked. The mathematics that includes virtual particles is the most accurate theory in the history of science. When we calculate the magnetic moment of the electron using quantum field theory, we get a number that agrees with experiments to 12 decimal places. 12! That's like predicting the distance from New York to Los Angeles and being accurate to the width of a human hair. Nothing in science has ever been this precise. And it only works because we include the effects of empty space not being empty. Now here's where things get uncomfortable. If the vacuum has energy, if empty space contains fluctuations, we should be able to calculate how much energy is there. Physicists have done this calculation many times using the most fundamental equations of quantum mechanics, and the answer is insane. The energy density of empty space, according to quantum field theory, should be about 10 to the power of 113 joules per cubic meter. That's a 1 followed by 113 zeros. That's more energy in 1 cubic centimeter of vacuum than in all the stars in the observable universe combined. Obviously, this is wrong. If empty space contained that much energy, the universe would have ripped itself apart the moment it formed. Galaxies wouldn't exist. Stars wouldn't exist. You wouldn't exist. The universe we see is far too calm, far too stable for that much vacuum energy. When astronomers measure the actual energy of empty space, they get a number that's 10 to the 120 times smaller. That's a discrepancy of 120 orders of magnitude. The biggest mismatch between theory and observation in the history of physics. We call this the vacuum catastrophe, or the cosmological constant problem. It's been called the worst prediction in physics. Something is deeply wrong with our understanding. Either our quantum theory is broken in some fundamental way, or the vacuum energy is there, but something cancels most of it out, or we're missing something so basic that future physicists will laugh at our confusion. 50 years of work, the greatest minds in theoretical physics, and nobody has solved it. This is what empty space does to physics. It breaks our equations. It humiliates our theories. It sits there looking innocent and empty while containing mysteries we can't unravel. But here's the strange part. Even though we can't explain why the vacuum energy is so small, we know it's not zero. In 1998, astronomers discovered that the universe's expansion is accelerating. Something is pushing space apart. Something is counteracting gravity on cosmic scales. We call it dark energy. And the leading explanation is that dark energy is the energy of empty space, the vacuum energy, not the absurd quantum prediction, something much smaller, but not zero. Empty space is pushing the universe apart. The nothing between galaxies is literally moving them away from each other. The void has a force, the emptiness has a pressure, and it's winning. Eventually, dark energy will push every galaxy so far apart that the night sky will go completely dark. Stars will fade. Isolation will become absolute. The universe will die of emptiness, except it won't be empty. The vacuum will still be there, still fluctuating, still birthing virtual particles that no one will ever observe, still humming with the zero-point energy that quantum mechanics demands. Even at the end of time, space won't be empty. It never was. Now, I want to tell you what this means for you, not for physics, not for cosmology, for you personally right now reading this. You are not sitting in empty space. You are swimming in fields. Right now, this instant, quantum fields are passing through your body. They fill your atoms. They occupy the space between your atoms. They are inside you and outside you, and there is no boundary where they stop. The Higgs field is inside your chest right now. You've heard of the Higgs boson, the God particle. But the boson isn't the important part. The boson is just a ripple. What matters is the field itself. And unlike other quantum fields, the Higgs field does something extraordinary. It's never zero, even in its lowest energy state. Even in the calmest possible vacuum, the Higgs field has a value. Everywhere, always, it fills all of space with a kind of invisible syrup, and that syrup is why you have mass. Without the Higgs field, electrons would be massless. They'd fly around at the speed of light like photons. Atoms couldn't form. Chemistry couldn't happen. You couldn't exist. Your entire body, every gram of it, owes its mass to the fact that empty space is filled with an invisible field that resists the motion of certain particles. You're heavy because empty space isn't empty. This broke something in my brain when I first understood it. I kept looking at my hands, at my body, thinking about the fact that my existence depends on a field I can't see, can't touch, can't detect without billion-dollar machines. A field that fills the vacuum like water fills an aquarium. I'm a fish that just discovered water. And so are you. We've been swimming in quantum fields our entire lives, every moment, every breath. The fields are invisible to us, not because they're hidden, but because they're everywhere. We have no contrast, no comparison. We can't see the medium we exist in any more than a fish can see the ocean. But it's there. It's always been there. And without it, there would be no there at all. Let me tell you the strangest implication of all this. Matter is not fundamental. You look at a rock and you think that's solid stuff, that's reality, that's what exists. Empty space is just the gaps between the real things. It's backwards, completely backwards. The fields are fundamental. The fields are what exist. Matter is just what happens when fields vibrate. Particles are temporary. Excitations are temporary. The fields are eternal. When a particle decays, it doesn't go into nothing. It transfers its vibration to other fields. The electron field might give its ripple to the photon field. Energy moves from one field to another, but the fields remain, always, forever. You are not a thing that exists in space. You are a pattern of vibrations in fields that fill all of space, a temporary arrangement, a wave that thinks it's separate from the ocean, but the ocean was there before you and will be there after you, and you were never anything other than ocean-shaped briefly into a wave. This is not mysticism. This is physics. This is what the mathematics tells us. This is what the experiments confirm. Empty space is not a void waiting to be filled with matter. Empty space is the foundation, the ground floor, the canvas, and matter is what gets painted on it, temporarily, briefly, while the fields are disturbed. I want you to look at the gap between your hands again. 6 inches of what your eyes call nothing, what your brain labels empty, what your intuition dismisses as absence. That gap is full, completely full. Every cubic millimeter is occupied by quantum fields. Every instant, virtual particles are being born and dying in that space. The Higgs field is there, giving mass to any particle that passes through. The electromagnetic field is there, ready to transmit light the moment something disturbs it. Electron fields, quark fields, neutrino fields, all of them overlapping, interpenetrating, filling every point. The gap between your hands contains more structure than your hands themselves. It contains the blueprint of reality, the machinery that makes physics work, the invisible substrate that everything else is built on. I spent years thinking about what emptiness really is, and I've come to a conclusion that still makes me uncomfortable. True emptiness doesn't exist. It might not even be possible. You can remove all the particles from a region of space. You can remove all the radiation. You can cool it to absolute zero, or as close as physics allows, and there will still be quantum fields. There will still be fluctuations. There will still be virtual particles flickering in and out of existence. The universe has no concept of nothing. Every time we try to create a void, the void pushes back. It fills itself with the minimum allowed activity. It refuses to be truly empty, as if emptiness itself is unstable, as if nothing is impossible. Maybe this is why there's something rather than nothing. Maybe the question, why does the universe exist, has a simpler answer than we thought. Maybe true nothingness can't exist. Maybe the quantum fields and their fluctuations are the default state. Maybe existence is not the mystery. Maybe nothingness would be the mystery if it could exist. We keep asking why there's something, but perhaps the real question is whether there could ever be nothing. And the answer, according to everything we know about quantum mechanics, is no. Emptiness is fiction. Fullness is fact. The void is a lie we tell ourselves because we can't see what fills it. Look at that gap between your hands one more time and know that you're looking at the most active, most energetic, most fundamentally important part of reality. You're looking at quantum fields in their resting state. You're looking at the vacuum that contains the energy of existence itself. You're looking at everything pretending to be nothing. And now you know the truth. Space was never empty. It was always full. And you've been swimming in it your whole life without knowing you were wet.